Guys, welcome back. Today we are going to graph linear inequalities. So for this first one, x is greater than or equal to -2. X, if we just thought of this as x equals -2, that's going to be a vertical line right here where the x value is -2. But since it's greater than or equal to, this line is not all there is to this graph. What this line is going to be actually is a border to our graph. This line is going to split this coordinate plane into two half planes. And one of those half planes will satisfy this inequality and the other will not. Now, as the border, we have to decide if that border is open or closed. If it's open, it'll be a dotted border. Closed will be solid. So since this says or equal to, it's going to be closed. So this will be a solid line right here where the x value is -2. And the way that we decide which half plane actually satisfies this inequality is by checking a point. We can check any point we want. Typically, the origin 0, 0 is the easiest. You can pick 1, 1. If those 2 points both happen to be on the line, you can pick 15, -2 if you want. Any point that you want, you can test. So since the origin isn't on the line, and it's typically the easiest, we'll just plug in the origin where the x value is 0. 0 is greater than or equal to -2. That happens to be a true statement, so that means that the origin satisfies this inequality, and so will any other point on that side of the line. So any point on the line and any point on the right side of this line will satisfy the inequality. Here in number 2, we have a y-intercept of -4. So we're going to start down 4 on the y-axis. And we have a slope of -2, so that's -2 over 1. We go down 2 and right 1. To keep that same slope, we go up 2 and left 1. So there's our slope of -2. And this one is less than but not equal to, so this border does not satisfy the inequality. So that border is open, it is a dotted line. So we will test the origin. 0 is less than -2 times 0 minus 4. So that 0 is less than -4. And that is not true. 0 is not less than -4. That is a false statement. So the origin right here does not satisfy the inequality. That means no other point over here will, but all the points over here on the other side will satisfy the inequality. So all points on this side and infinitely close to our line, but the points on the line do not satisfy the inequality. So next we have a y-intercept of 2 and a slope of 3, up 3 over 1. And we can go down 3 and left 1 and keep that same slope. And it is underlined, so it is a solid line. And 0 is greater than or equal to 3 times 0 plus 2 will tell us where to shade. So 0 is greater than or equal to 0 plus 2. 0 is greater than or equal to 2. That is false. So the origin gave us a false statement, so I shade the side that does not include the origin. Everything over here would have given us a true statement. So all this shaded region and everything on the line will satisfy that inequality. Okay, so now we come up to a different kind of situation. It's not just a line, it's an absolute value, so we're going to get a v. So we'll make a chart of x and y. Okay, so if we put in, say, 0, plus 3 is 3. Absolute value is 3. So we get the point 0, 3. And we can choose to go right or left. In this case, I've got a lot of graph over here, so I think I'm going to go left. -1 plus 3 is 2. Absolute value is 2. So -1, 2. -2 plus 3 is 1. Absolute value is 1. -2, 1. -3 plus 3 is 0. Absolute value is 0. -3, 0. -4 plus 3 is -1. Absolute value is 1. Okay, so there is the V. You see the slope on each side. We can continue that slope. It's not equal to, so it's going to be dotted. Okay, so there's our V. But then we test the origin to see if we should shade where the origin is or where the origin is not. So we can plug in that origin. 0 is less than the absolute value of 0 plus 3. 0 plus 3 is 3, and the absolute value is 3. 0 is less than 3 is a true statement. The origin is here outside of the V, so I'm going to shade outside of the V. Okay, so number 5. Y is greater than the absolute value of x minus 2. So I'll make a chart again and start with x equals 0. Minus 2 is -2. The absolute value of that is 2. So we've got the point 0, 2. Let's try 1. Minus 2 is -1. Absolute value is 1. 2. Minus 2 is 0. Absolute value is 0. 3 minus 2 is 1. Absolute value is 1. And we've got our V. Once again, it's not underlined, so it is dotted. So there's our V. Now we decide where to shade. 0 is less than the absolute value of 0 minus 2. Okay, so that's -2. Absolute value is 2. 0 is greater than, I think I said less than, but 0 is greater than 2. And that statement is false. 0 is outside of the V, and it made a false statement, which means that inside of the V will make a true statement. Here's another line. The y-intercept is 4. The slope is -1/2, so that's down 1 and right 2. And we can go up 1 and left 2. It's underlined, which means or equal to, so it will be solid. So everything on this line will satisfy the inequality. And 0 is less than or equal to -1/2 times 0 plus 4. So 0 is less than or equal to 4. That is a true statement. The origin makes a true statement, so everything else on the same side of the line will also make a true statement. Okay, so everything down here in the shaded region and everything on the line will make a true statement that will satisfy the inequality. Number 7, we have a compound inequality. So what we actually have is a line here that we need to graph, and then we'll have to graph another one. So this one has a y-intercept of -3 and a slope of 3/4, up 3 over 4. And it's underlined, so that is solid. And this line, if I test the origin, I get 3/4 times 0 minus 3 is less than or equal to 0. So -3 is less than or equal to 0. That is true. This line wants me to shade toward the origin, which is up. That line wants me to shade up. The next line has a y-intercept of 4, has a slope of 4/5, up 4 and right 5 or down 4 and left 5. And it is underlined, so this one is also solid. And 0 is less than or equal to 4/5 times 0 plus 4. So 0 is less than or equal to 4. That is true. So this one wants me to shade down. I've got one line that wants me to shade up infinitely, and another line that wants me to shade down infinitely. The part that would get shaded both times is what satisfies both inequalities. So everything on the two lines and everything between them. I'm going to exaggerate this, but these are not parallel lines, so eventually they're going to intersect, and it would be everything up to that intersection and then infinitely this way, to the right. And last, we've got another compound inequality. There's a line right there. And we can graph this one using the x and y intercepts. So if we put in a 0 for x, we get -4 and -2y. And when we divide by -2...
Teachers, pardon the interruption. At this time...
So we can divide here and get the y-intercept as 2. And then if I put in a 0 for y, I get 0 here, and the x-intercept is -4. And that line is solid. So I'm going up 2 and over 4, which is the same as up 1 and over 2. So there's my first line. And if I put in the origin, I have -4 is less than or equal to 0 minus 0. -4 is less than or equal to 0 is true, so this one says shade down toward the origin. My other line, if I put in a 0 for x, I'm going to divide by -2. 6 divided by -2 is -3, so I've got a y-intercept of -3. If I put in a 0 for y, I get -2 times 0, which is 0. So x is 6. So the x-intercept is 6. That really puts me 1 off the graph. So I'm going up 3 and over 6, which simplifies to up 1 and over 2, which is the same slope as the first line. So these two actually are parallel. So I'm going to go down 1 and left 2. And it is not underlined, so this one is dotted. So these two will never intersect, so it won't come to any particular point. It's just going to be this corridor right here between them forever. Now this one, if I put in the origin, I get 0 minus 0 is less than 6, and that is true. So it shades up. So what satisfies the inequality is everything on this line, everything between the two lines, but not the points on this line.
Let's finish with a review of graphing piecewise functions. So here I've got f of x equals -x. So this is going to be a horizontal line, but only on the domain of x is less than or equal to -4. Okay, so I'm going to just put in a little dotted line here where x is -4. And I can only graph on the less than side, which is the left side of that line. So -x, that's a horizontal line down here. And I'm going to put a little circle right there on the edge of that domain, and I can only graph to the left of that line where where x equals -4. Now it does say less than or equal to, so I actually want to fill that in. Okay, so there's my first line. Y equals -6, but only for x is less than or equal to -4. Okay, the next part of my piecewise function is y equals -1/2 x. And that is only graphed between -2 and 4. So I'll put dotted lines here for the left edge and the right edge of the domain. -2 and 4. So I'm going to graph somewhere in here between -2 and 4. So it's y equals -1/2 x, and that's plus 0. So I have a y-intercept of 0 and a slope of -1/2. So I can go down 1 and right 2. I can do that again, and when I get to the edge of the domain, I'm just going to put a circle there. And I can go up 1 and left 2, and I'll put a circle there because I'm on the other edge of the domain. So it's a line segment. So what we've got so far is a ray and a line segment. Now this one is greater than -2, less than or equal to 4. So at 4, I actually want to fill that in because it can be where x is equal to 4. Okay, and the last part is y equals x minus 5, but only for x is greater than 4. And I've already got a dotted line on that edge of the domain, and now I can graph to the right, to the side that is greater than 4. So my y-intercept is -5, so I'm actually going to come down here to a y-intercept of -5, but I can't graph that because it's not inside my domain. My domain is over here. But I still have to start here. And then I can follow the slope, which is 1, up 1 and right 1, and I still can't graph, up 1 and right 1, still no point there, up and right, and now I have reached the domain. I can put a circle there, and then I can continue up 1 and right 1 until I get to the edge of the graph. Okay, and then I have to ask, do I want to fill that in? It's greater than but not equal to, so I want to leave that open. Okay, because x cannot equal 4, it has to be greater than 4. Okay, so here I have x plus 3, but only for x's that are less than or equal to -3. So I've got a domain boundary right here. I can only graph on the less than side, the left side of that boundary. Okay, so I'm graphing x plus 3, so I have a y-intercept of 3, which I can't actually put a point for because it's on the wrong side of this boundary. Okay, the slope is 1, so up 1 and right 1, but I'm running away from my boundary. So I'll go back here, and in order to keep a positive slope, I could go down and left. So down 1, left 1, down 1, left 1, down 1, left 1, and there I am at the edge of my domain. And I'll continue down 1 and left 1. And that ray is the first part, but do I want to fill that in? Less than or equal to -3. So yes, I want to fill it in. Next is x squared. Okay, y equals x squared. That's a parabola. And I can only graph it between -1 and 2. So x values from -1 to +2. Okay, let's just make a t-chart for this one. Okay, so I'll start at -1. And if I do -1 squared, I get 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, so I've gone all the integer values for x from -1 up to 2. So I can start to plot these. I've got -1, 1, and I'll put a circle there because it's on the edge of the domain. 0, 0. 1, 1. 2, 4, and I'll put a circle there. Okay, so this is the parabola, or at least the part of the parabola. So it's greater than -1, so I want to leave that open. Less than or equal to 2, so I want to close that one. And the last part is -1. Y equals -1, so this is a horizontal line, but only for x's that are greater than 4. Okay, so y equals -1, which is right here, but only greater than x equals 4. Okay, not equal to, so I want to leave that one open.